Picture a world of eternal ice, where the landscape is painted in shades of pristine white and blue. This is no ordinary celestial body, for here, cosmic geysers erupt with magnificent force, launching jets of water into the vast expanse of space. These plumes rise miles above the surface, a spectacular display of nature's power in the cold reaches of our solar system. Beneath this frozen crust lies a realm of mystery and wonder. An ocean, hidden from view, churns with potential. Its dark waters conceal secrets that have tantalized scientists and fueled the imagination of explorers. This is a place where the impossible becomes possible, where the boundaries of life as we know it are constantly being redefined. Welcome to Enceladus, the enigmatic moon of Saturn. This small world, barely 500 kilometers in diameter, stands as a testament to the surprises our universe still holds. It challenges our preconceptions about where life might exist and invites us to reconsider the very definition of habitability in the cosmos. What if I told you that one of the most promising places to find extraterrestrial life isn't the red plains of Mars, but a tiny, icy moon at the edges of our solar system? A world that, despite its frigid exterior, might harbor conditions startlingly similar to those that birthed life on our own planet? Imagine a place where, at this very moment, hydrothermal vents could be active, mirroring the life-sustaining environments found in the depths of Earth's oceans. These underwater oases, known to support thriving ecosystems on our planet, might also exist light-years away, hidden beneath the icy crust of Enceladus. Today, we're embarking on an extraordinary journey. We'll dive into the frozen depths of Enceladus, peeling back layers of ice to uncover the reasons why this small Saturnian moon has captured the imagination of scientists worldwide. From its cracked, icy surface to its potentially life-harboring subsurface ocean, we'll explore every facet of this cosmic wonder. Feeling the chill of excitement from our icy adventure? Don't let your curiosity freeze over. If you're ready to continue this cosmic exploration, hit that like button faster than an Enceladus geyser eruption. And while you're at it, why not subscribe to Exploring the Universe? It's your ticket to more mind-bending space odysseys. Trust us, your feed will thank you for the coolest content this side of Saturn's rings. Enceladus, one of Saturn's most intriguing moons, is a celestial body that packs a remarkable array of features into its diminutive size. Let's delve into the key aspects that make this icy world so fascinating. Enceladus measures a mere 504 kilometers, 313 miles, across, making it Saturn's sixth largest moon. To put this into perspective, Enceladus is about 7 times smaller than Earth's moon. If Earth were the size of a basketball, Enceladus would be roughly the size of a golf ball. This small size initially led scientists to believe Enceladus would be a cold, inactive world. However, its diminutive stature belies the dynamic processes occurring beneath its icy shell. William Herschel, the renowned British astronomer also famous for discovering Uranus. Date: August 28, 1789. Herschel's discovery came just 8 years after he discovered Uranus, during a period of rapid advancement in telescope technology and astronomical observations. The moon was named after the giant Enceladus from Greek mythology, who is said to be buried under Mount Etna in Sicily. Enceladus is the 6th largest moon of Saturn, nestled within the planet's E-ring. Mean distance from Saturn, approximately 238,000 kilometers, 148,000 miles. Orbital period, 32.9 hours. Meaning Enceladus completes a full orbit around Saturn in just over a day. Like Earth's moon, Enceladus is tidally locked to Saturn, always presenting the same face to the planet. Relation to Saturn's rings: Enceladus orbits within the E-ring, the outermost of Saturn's main rings. Remarkably, Enceladus is the primary source of material for the E-ring, ejecting icy particles through its famous geysers. Despite its small size, Enceladus plays a crucial role in shaping Saturn's environment. Its geologic activity influences the composition and structure of Saturn's rings. The moon's potential habitability has made it a prime target for astrobiological studies. Enceladus serves as a prime example of how even small celestial bodies can hold immense scientific importance. Its discovery over 2 centuries ago opened the door to a world of questions and possibilities that continue to captivate researchers and space enthusiasts alike. As we continue our exploration of this icy moon, we'll uncover the remarkable features and phenomena that make Enceladus one of the most exciting destinations in our solar system. Enceladus, despite its small size, boasts one of the most intriguing surfaces in our solar system. Its icy exterior holds clues to the dynamic processes occurring beneath and offers a visual spectacle that has captivated scientists and space enthusiasts alike. Albedo. Enceladus has the highest albedo of any known body in the solar system, reflecting up to 99% of the sunlight that hits its surface. For comparison, Earth's albedo is about 0.3, meaning it reflects 30% of incoming sunlight. Even fresh snow on Earth typically reflects only about 90% of sunlight. The high reflectivity is due to the surface being composed almost entirely of water ice. The ice is constantly refreshed by the Moon's geologic activity, maintaining its pristine appearance. From space, Enceladus appears as a brilliant white orb, standing out starkly against the darkness of space and the muted colors of Saturn's other moons. This high reflectivity means that despite its distance from the Sun, Enceladus's surface temperature is extremely cold, averaging about -201 degrees Celsius -330 degrees Fahrenheit. Smooth plains and fractured regions. Enceladus's surface is a study in contrasts, featuring areas of extreme smoothness juxtaposed with highly textured regions. Large areas of Enceladus, particularly in the equatorial regions, are incredibly flat and smooth. These plains are some of the smoothest terrains found in the solar system, rivaling the smoothness of the ice sheets of Europa, Jupiter's moon. The smoothness suggests recent resurfacing, possibly due to cryovolcanic activity. Other areas of Enceladus are crisscrossed with a complex network of cracks, ridges, and chasms. These features range from small, fine cracks to large canyons that can be several kilometers deep. The variety of fracture patterns suggests a long and complex geological history. Interestingly, Enceladus has relatively few impact craters compared to other icy moons. The lack of craters, especially in certain regions, is evidence of active resurfacing processes. Perhaps the most famous features on Enceladus are the so-called tiger stripes at its south pole. These are four prominent, parallel linear depressions in the south polar region, each about 130 kilometers long, 2 kilometers wide, and 500 meters deep. The four main tiger stripes are named after cities featured in the collection of Middle Eastern folktales, 1001 Nights: Alexandria, Cairo, Baghdad, and Damascus. These fissures are the source of the dramatic plumes of water vapor and ice particles that erupt from Enceladus. The Cassini spacecraft directly sampled these plumes, finding water vapor, ice particles, salts, and organic compounds. The tiger stripes are significantly warmer than the surrounding areas, with temperatures reaching as high as -93 degrees Celsius -135 degrees Fahrenheit compared to the surrounding -201 degrees Celsius. Scientists believe these fissures may be the result of tidal stresses caused by Saturn's gravitational pull, coupled with internal heating mechanisms. The tiger stripes are thought to be direct conduits to the subsurface ocean of Enceladus, making them key targets in the search for potential extraterrestrial life. The enigmatic surface of Enceladus, from its brilliantly reflective ice to its mysterious tiger stripes, tells a story of a small but extraordinarily active world. Each feature provides clues about the moon's past and present, hinting at the possibility of a habitable environment beneath its icy crust. As we continue to study this fascinating moon, its surface remains a key to unlocking the secrets hidden in its depths. The Cassini-Huygens mission was a joint endeavor between NASA, the European Space Agency, and the Italian Space Agency. Launched in 1997, it arrived at Saturn in 2004 and operated until 2017. To study Saturn, its rings, and its moons in unprecedented detail. The spacecraft was equipped with an array of instruments, including cameras, spectrometers, and particle detectors. These tools allowed for comprehensive analysis of Saturn's system, including Enceladus. In early 2005, Cassini's magnetometer detected a disturbance in Saturn's magnetic field near Enceladus. This unexpected finding hinted at the presence of an atmosphere around the moon. On July 14, 2005, Cassini flew within 175 kilometers of Enceladus's surface. During this close flyby, the spacecraft directly observed plumes of water vapor and ice particles erupting from the moon's south polar region. This discovery was revolutionary, as it provided clear evidence of ongoing geological activity on a body previously thought to be inert. It immediately elevated Enceladus to one of the most intriguing objects in the solar system for potential habitability. Enceladus experiences strong tidal forces due to its proximity to Saturn and its elliptical orbit. As the moon moves closer to and farther from Saturn in its orbit, it experiences varying gravitational pull. This gravitational variation causes Enceladus to be slightly stretched and compressed as it orbits. The internal friction from this constant reshaping generates heat within the moon. This tidal heating is believed to be the primary energy source maintaining Enceladus's subsurface ocean in a liquid state. It also likely drives the geological activity observed on the surface, including the eruption of the plumes. The plumes are primarily composed of water vapor and ice particles. This directly indicates the presence of liquid water beneath the surface. Salts. Sodium and potassium salts have been detected in the plumes. Their presence suggests that the subsurface ocean is in direct contact with a rocky core, allowing for mineral leaching. Complex organic molecules, including some with masses up to 200 atomic mass units, have been found in the plumes. This includes compounds like methane, which on Earth can be produced by both geological processes and living organisms. Traces of ammonia, carbon dioxide, and various noble gases have also been detected. The plume material is ejected at speeds ranging from 300 to 500 meters per second, with an average of about 400 meters per second. This is equivalent to about 1,440 kilometers per hour or 894 miles per hour. These speeds exceed Enceladus's escape velocity of about 240 meters per second. As a result, some of the ejected material escapes the Moon's gravity entirely. The high ejection velocity allows the plumes to reach heights of up to 500 kilometers above the surface. The E-ring is Saturn's second outermost ring and the widest, spanning from 180,000 to 480,000 kilometers from Saturn's center. Enceladus orbits Saturn within this ring. The ice particles ejected by Enceladus's geysers that escape its gravity become the primary source of material for the E-ring. It's estimated that Enceladus adds several hundred kilograms of material to the E-ring every second. Without constant replenishment from Enceladus, the E-ring would dissipate relatively quickly due to various loss mechanisms. The ongoing activity of Enceladus thus plays a crucial role in maintaining this feature of the Saturnian system. The connection between Enceladus and the E-ring provides a unique opportunity to study the Moon's internal composition by analyzing ring particles. It also demonstrates the significant impact that even a small moon can have on its planetary environment. These discoveries and phenomena highlight Enceladus's status as one of the most dynamic and potentially habitable bodies in our solar system, making it a prime target for future exploration and the search for extraterrestrial life. Are these cosmic geysers making your curiosity erupt like Enceladus plumes? Well, buckle up for an even deeper dive into the wonders of our solar system. If you're feeling that icy thrill of discovery, why not ride that wave of excitement? Smash that like button faster than an ice particle shooting out of Enceladus tiger stripes. And while you're at it, why not subscribe to our channel? It's your ticket to more mind-bending planetary explorations. By subscribing, you'll be the first to know about our upcoming cosmic adventures. From the methane lakes of Titan to the volcanic hellscape of Io, we're your personal tour guides to the most extreme and fascinating places in our celestial neighborhood. So, what do you say? Are you ready to embark on more interplanetary journeys with us? Hit that subscribe button and let's continue our cosmic odyssey together. Beneath Enceladus' icy crust lies one of the most exciting discoveries in recent planetary science: a global subsurface ocean. This hidden sea has transformed our understanding of this tiny moon and revolutionized our search for potential habitable environments in the solar system. Cassini's gravity measurements revealed mass anomalies suggesting the presence of liquid water beneath the South Polar region. Further analysis indicated that this liquid layer likely extends globally. Careful observations of Enceladus' slight wobble as it orbits Saturn, known as libration, provided strong evidence for a global liquid layer. The amplitude of this wobble is too large to be explained by a solid interior, indicating a decoupling between the surface ice shell and the rocky core. The presence of salts and organic compounds in the plumes suggests direct interaction between liquid water and a rocky core, consistent with a global ocean model. Thermal measurements of the South Polar region indicate more heat output than can be explained by radioactive decay alone, supporting the presence of a liquid water layer. Current estimates suggest the ocean could be 5 to 30 kilometers deep. This thickness varies depending on location, with the ocean likely being deeper near the South Pole. The ocean is capped by an ice shell estimated to be 20 to 25 kilometers thick on average. At the South Pole, where the tiger stripe fissures are located, the ice shell may be as thin as 2 kilometers. Despite Enceladus' small size, its ocean may contain as much water as Earth's Arctic Ocean. To put the depth of Enceladus Ocean into perspective, let's compare it to Earth's oceans. Mariana Trench, the deepest part of Earth's oceans, the Challenger Deep in the Mariana Trench, reaches about 11 kilometers. Enceladus Ocean, potentially up to 30 kilometers deep, could be nearly 3 times deeper. Average ocean depth. Earth's average ocean depth is about 3.7 kilometers. Enceladus Ocean could be up to 8 times deeper than Earth's average. proportional depth relative to the size of the body. Enceladus ocean is even more impressive. While Earth's oceans occupy a thin layer on its surface, Enceladus ocean could comprise a significant portion of the Moon's total volume. Pressure conditions. The extreme depth of Enceladus ocean means that pressure at its bottom could be much higher than in Earth's deepest ocean trenches. This high pressure, combined with potential hydrothermal activity, could create unique chemical and physical conditions unlike anything we see in Earth's oceans. The discovery of this deep, global ocean on Enceladus has profound implications for astrobiology. It provides all the key ingredients thought necessary for life: liquid water, energy sources, and organic compounds. As we continue to study this remarkable moon, its subsurface ocean remains one of the most tantalizing environments in our search for potential extraterrestrial life in our solar system. The discovery of Enceladus' subsurface ocean has ignited excitement in the scientific community about the potential for life beyond Earth. This small Saturnian moon has rapidly become one of the most promising locations in our solar system for the search for extraterrestrial life. The global subsurface ocean provides a stable liquid water environment. Liquid water is essential for life as we know it, serving as a solvent for biochemical reactions. Cassini's instruments detected various organic molecules in Enceladus plumes, including methane, ethane, and more complex compounds. These organic molecules are the building blocks of life as we know it. Tidal heating from Saturn provides a consistent energy input. Potential hydrothermal activity at the ocean floor could offer localized energy-rich environments. Evidence for hydrothermal activity. The presence of silica nanoparticles and molecular hydrogen, H2, in the plume suggests ongoing hydrothermal reactions between the rocky core and the ocean. On Earth, deep-sea hydrothermal vents support rich ecosystems independent of sunlight. These ecosystems rely on chemosynthesis rather than photosynthesis, with microorganisms deriving energy from chemical reactions. If similar hydrothermal systems exist on Enceladus, they could provide the chemical energy and nutrients necessary to support microbial life. Psychrophiles, cold-loving organisms. Given the low temperatures of Enceladus ocean, any life would need to be adapted to cold conditions. On Earth, psychrophilic microbes thrive in polar regions and deep oceans. Chemolithotrophs. These organisms derive energy from inorganic chemical reactions. They could potentially utilize the hydrogen and other chemicals produced by hydrothermal activity. Methanogens. The presence of methane in Enceladus plumes could be indicative of methanogenic life forms. These organisms produce methane as a byproduct of their metabolism. Halophiles. Given the saltiness of Enceladus ocean, any life forms would need to tolerate high salt concentrations. Barophiles. The high pressure at the bottom of Enceladus deep ocean would require organisms adapted to extreme pressure. While these types of extremophiles provide models for potential life on Enceladus, it's important to note that any life there could be fundamentally different from Earth life, potentially using different biochemistries adapted to the unique conditions of this alien world. The tantalizing possibility of life on Enceladus has spurred numerous proposals for future missions to explore this fascinating moon in greater detail. Enceladus Lifefinder. A proposed NASA mission to fly through Enceladus plumes multiple times. It would analyze plume material for signs of biological processes. Explorer of Enceladus and Titan. A proposed mission by the European Space Agency to study both Enceladus and Titan. It would include an orbiter and potentially a lander for Enceladus. Enceladus life signatures and habitability. Another NASA concept focused on searching for biosignatures in the plumes. A concept combining an orbiter and lander, allowing for both global mapping and direct surface/plume sampling. Penetrating the ice shell. Developing technologies to drill or melt through kilometers of ice without contaminating the pristine environment below. Ensuring reliable communication between a subsurface probe and the surface/orbit. Developing power systems that can operate in the cold, dark conditions beneath the ice. Designing systems that can withstand the harsh radiation environment of Saturn's magnetosphere. Creating AI systems capable of making decisions independently due to the communication delay with Earth. Developing instruments that can collect and analyze samples in situ under extreme conditions. Looking for organic molecules indicative of biological processes, such as specific amino acids or lipids. Analyzing the ratios of certain isotopes, which can be influenced by biological activity. Searching for complex organic molecules that are more likely to be produced by living organisms than by abiotic processes. Directly imaging plume particles to look for cell-like structures or fossils. Detecting gases like methane or hydrogen sulfide in ratios that suggest biological production. examining the handedness of organic molecules, as life tends to prefer one chiral form over another, looking for unexpected chemical or redox gradients that could be maintained by biological activity, observing changes in chemical compositions over time that might indicate biological cycles. The discoveries made on Enceladus have had a profound impact on the field of astrobiology, challenging our preconceptions about where life might exist in the universe and how we should search for it. Redefining habitability. Traditionally, the habitable zone was defined as the region around a star where liquid water could exist on a planet's surface. Enceladus demonstrates that habitable environments can exist far beyond this narrow definition. Tidal heating, as seen on Enceladus, shows that moons of gas giants can maintain liquid water even far from the Sun. This expands the potential for habitable worlds to include the outer solar system and exomoons of distant gas giants. The discovery of Enceladus' global ocean suggests that subsurface oceans might be common in icy worlds. This shifts focus from surface habitability to potential subsurface biospheres. Enceladus plumes provide a unique opportunity to sample a subsurface ocean without landing or drilling. This model could be applied to other worlds with potential cryovolcanic activity. The methods used to detect Enceladus ocean, e.g., gravity measurements, libration, can be applied to other icy bodies. The search for biomarkers in Enceladus plumes informs strategies for detecting life on other worlds with similar characteristics. Enceladus shows that even small moons can harbor complex, potentially habitable environments, encouraging closer study of similar bodies. Like Enceladus, Europa has a subsurface ocean beneath an icy crust. Both moons experience tidal heating from their parent planets. Europa is larger and its ocean is likely deeper and older than Enceladus. Europa may have occasional plume activity, but it's not as consistent as Enceladus. Insights from Enceladus inform our approach to exploring Europa, such as the upcoming Europa Clipper mission. Comparing these two worlds can help us understand the diversity of icy moon environments. The exploration of Enceladus and its implications extend beyond scientific discovery, touching on fundamental questions about life and our place in the universe. Enceladus reminds us that life can potentially thrive in environments we once thought inhospitable. It challenges us to expand our definition of extreme environments. The moon's unique conditions suggest that life might adapt to a wider range of environments than we previously imagined. This encourages us to think creatively about potential forms of life. Enceladus demonstrates that sunlight isn't necessary for maintaining a potentially habitable environment. It highlights the importance of considering alternative energy sources for life. The possibility of life on Enceladus reminds us of our small place in a vast, potentially life-filled universe. It challenges our Earth-centric view of life and habitability. The search for life on Enceladus prompts us to reconsider what it means to be alive and how we define life. It raises questions about the uniqueness of Earth life and the potential commonality of life in the universe. The possibility of life on Enceladus raises questions about how we should approach the exploration and potential exploitation of other worlds. It underscores the importance of planetary protection policies. The challenges of exploring Enceladus' subsurface ocean mirror those of exploring Earth's deep oceans. Both require developing technologies to operate in extreme pressure, cold, and dark conditions. Just as deep-sea exploration on Earth has revealed surprising ecosystems, space exploration continues to challenge our expectations. Both fields remind us of the vastness of the unknown, even in our own cosmic backyard. The study of Enceladus, like deep-sea exploration, requires collaboration across multiple scientific disciplines. Techniques and technologies developed for one field often find applications in the other. Both deep-sea and space exploration capture the public imagination, inspiring us to push the boundaries of human knowledge and capability. They remind us of the importance of exploration and discovery in the human experience. Studying extreme environments, whether in Earth's oceans or on distant moons, provides insights into the adaptability and resilience of life. This knowledge is crucial as we face environmental challenges on our own planet. Enceladus serves as a powerful reminder that even in our own solar system, we can find worlds that defy our expectations. What was once thought to be a small, frozen, inactive moon has turned out to be one of the most intriguing and potentially habitable places in our cosmic neighborhood. The discoveries on Enceladus prompt us to question our assumptions about where life might exist and what conditions are truly necessary for habitability. It encourages us to approach planetary exploration with an open mind, ready to be surprised by the ingenuity of nature. Despite all we've learned, Enceladus still holds many secrets. The exact nature of its interior, the full composition of its ocean, and the potential for life remain tantalizing mysteries. This moon reminds us that scientific discovery is an ongoing process, with each answer often leading to new, deeper questions. The challenges of exploring Enceladus drive innovation in spacecraft design, sensor technology, and data analysis techniques. These advancements often have applications beyond space exploration, benefiting various fields on Earth. The study of Enceladus brings together experts from diverse fields: planetary science, geology, biology, chemistry, and more. This collaboration fosters a holistic approach to understanding our universe and can lead to unexpected breakthroughs. Discoveries like those on Enceladus capture the public imagination and inspire young people to pursue careers in science and engineering. They remind us of the wonder and excitement that space exploration can bring to society as a whole. Exploring worlds like Enceladus challenges us to reconsider our place in the universe and the potential ubiquity of life. It encourages a cosmic perspective that can influence how we view our own planet and our responsibilities as a spacefaring species. Much of our outer solar system remains unexplored. What might we find on the other icy moons of Saturn and Jupiter, or in the Kuiper Belt? Could there be other subsurface oceans, or entirely different types of potentially habitable environments we haven't yet imagined? As our technology improves, we gain the ability to detect subtler signs of geological activity and potential biosignatures. What might we discover when we can probe these distant worlds with even greater precision and sensitivity? Enceladus has already shifted our understanding of habitability. What other fundamental shifts in our understanding of planetary science and astrobiology might be waiting for us? Could future discoveries completely redefine our concepts of life and the conditions necessary for its existence? How might future discoveries in the outer solar system change our understanding of Earth's history and the origins of life? What insights might we gain about the formation and evolution of planetary systems, both our own and those around other stars? If this journey to Enceladus has left you thirsting for more cosmic knowledge, you're on the right track. The icy, mysterious worlds of our solar system are waiting to be explored, and we're just getting started. Ready to dive deeper into the frontiers of planetary science? Here's how you can continue your cosmic adventure with us at Exploring the Universe. Smash that like button. It helps our content reach more curious minds like yours. Subscribe to our channel. By hitting that subscribe button, you'll ensure you never miss our latest explorations of the solar system's most enigmatic worlds. Ring the notification bell to be the first to know when we upload new videos. From the methane lakes of Titan to the volcanic hellscapes of Io, we've got a universe of content coming your way. Share this video with fellow space enthusiasts. Spread the wonder of cosmic exploration and spark conversations about the potential for life beyond Earth. Leave a comment telling us which mysterious world you'd like us to explore next. Your curiosity drives our content. Check out our playlist on potential habitable worlds for more in-depth explorations of places like Europa, Titan, and even exoplanets that might harbor life. Remember, every like, share, and subscription fuels our mission to bring the wonders of the universe to your screen. Together, we can continue to push the boundaries of knowledge and explore the profound questions that arise as we venture into the cosmic unknown. So, are you ready to embark on more mind-bending journeys through space and time? Join us at Exploring the Universe, where every video is a new adventure in unraveling the mysteries of our cosmic home. The universe is vast, and the possibilities are endless. Let's explore them together.